Hello everyone, this is Brian from True Sustainability. We're going to go through a hydroponic system here at Mesa Community College. I have a student here, Jack. He's going to explain a lot of what's going on here so that we can figure out what we do in a hydroponic system. So let's go ahead and get things started, and I will introduce you right now.
Hey everyone, my name is Jack McGregor. I'm a sustainable agriculture student here at Mesa Community College. This is my second semester I've been here, and I am now doing a RPS position with the community college, so doing a student and work position now. I mainly focus on taking care of our greenhouse and the hydroponic tomato systems we have here, but I do everything goes from taking care of the farm, the garden, these systems, to just regular maintenance and basically everything that needs to be done around here. So that's who I am, and let's get into the systems.
All right, let's go.
So we'll start here. This is our cooling system we use. It's a sump and pump tank, and then also basically a large
evaporative
cooler.
cooler?
Exactly, basically a large evaporative cooler. So we start here with our sump tank. This holds about 200, 300 gallons of water, and then it'll get pumped here and it'll disperse all through the top. And as the water drains down, we have 5 fans on our back wall there, all the way at the bottom, which will then pull air through the greenhouse. So you have air going through these cooled pads, and then it will cool the greenhouse through disposing that air. So this is our cooling system we use here, and then our heating system is actually all directly under the ground. We use a system of underwater tubes that will push hot water directly under our concrete here, and then the heat will rise.
Do you know what the temperature is that's maintained in the building year-round?
Yeah, so actually if you want to follow us over here, we have multiple hanging temp sensors that check the greenhouse. So we also have just this little guy here. So right now we're keeping it at 75 degrees. And I would say mainly in the day, it gets about 80 degrees the highest, and then probably 65 the lowest at night. Okay. So right now we're keeping our shade coverings over the entire time, just keeping that heat to not let it escape. And we get pretty good light here in Arizona. But diving into our tomato systems, we have 3 different tomatoes going right now: Sakura, Kachutso, and then one other one. There are 2 indeterminates and 1 determinate. So the indeterminate tomatoes, they'll continue growing, where the determinate tomatoes, like these guys right here, they'll stop. So they'll probably get about maybe a foot taller, and then they'll finish out. But you can see in this row, they are much taller already, and they'll continuously grow all the way to the top. So what we're doing is here, we're mimicking kind of the system they have going down at the U of A right now, where we'll grow tomatoes vertically and have the roots. Right now we're using this is rock wool, so it's very similar to a fiberglass material. So it's spun material that's used as a grow medium.
So why are you using that instead of like peat moss, for example?
So instead of using, we chose this one. We were gifted this from a different college, so we already had this. We didn't have to source those resources. And then peat moss, it can have a little bit of a tough time because, like, if it gets dry, it becomes hydrophobic, so it won't absorb water. And then it's also just a lot cleaner doing the rock wool. The rock wool, it can also be used for about 2 years. But the only bad part about it is there's no recycling after those 2 years. So it's a win-lose kind of situation right there. But we're mainly using it because we already have the supplies, and it just works with the system we're going with.
Yeah, that's definitely sustainable, you know, if you're using product from somebody else and you got it for free. So,
So we start here with these cubes. We planted these about 2-3 months ago, and then once they got to a big enough size, I came and cut these little boxes into these slabs right here, and you can show them there, and then we'll put those cubes directly, and the roots will actually, it's really hard, you can see I can't even pull it up, but the roots will actually go directly straight into that.
Okay, so they're embedding themselves into the next substrate.
And then eventually the roots will grow out so much that they'll come out and then wrap around the floor here, and they'll basically be a just long train of roots. So that's pretty much our kind of plan with the tomatoes we have going right now. This system's really new. We've had the supplies for a while now, but we've just started building this last semester. So everything you see here was put in from August to now. So not that old. Like I said, these plants are about 2.5 months old, maybe 3 months. So really new, but we're basically mimicking kind of the U of A right now, seeing what works here, and then we're gonna go from there. So
so you have like a drip system going to each one of these plants,
yeah,
right?
exactly. If you want to come over here, you can go. So right now we're using the dosatron system, and we have 3 different buckets going. We have our acid bucket, our B, and then A bucket. This is going to be that B bucket's really dark red, going to have stuff like iron, and then this will be our A bucket. So light blue, and then they'll get pumped up by the dosatrons here, and we have it set to 200 parts per million right now. And then once following the dosatron, they'll come around here, go up that gray tube, follow around, and then they'll come down. Each of these tomatoes have one of these black tubes that go directly down to this pipe here, which runs into, there is 12 of these different feedings, and then once it hits here, it'll be separated into another 12 tubes that go directly into the rock well tubes.
Okay.
So that's the system we use.
So 200 parts per million.
200 parts per million.
Okay.
Yep.
And then you said that in bucket B is going to be more like your irons. What, magnesium?
Yeah, once we finish here, I can actually get you guys the list so we can show exactly what goes into here.
Okay.
I don't honestly have that memorized, but we have a whole mathematical sheet that shows the weights of all of our chemicals we use, and then we'll measure them out, and then they'll go into these tanks.
So that's a really, really important part, everybody, to understand about hydroponic systems. Is it's very, very, very much calculated on the nutrients, and you're going to have exact measurements on each one of these cups that you put into these containers. The dosatron is going to, like I said, it has a specific dosage that's for a specific plant. So they're growing tomatoes right now, but if they were growing something else, then the dosatron would be dosed to a different amount. So it's important that you understand that it's very scientific, very mathematical, when you're talking about these hydroponic systems, and if you get the dosing incorrect, it's going to waste a lot of nutrients, and also the water that you put into the system. These actually look like they don't require too much water. How many times do you think that the dosatron goes off every hour?
So the dosatron goes off for 6 minutes, a couple times a day. I'm trying to remember the exact set ratio we have it going, but it waters for 6 minutes at a time. So
6 minutes at a time is hardly anything.
It is. And I want to say it's about 5 times every day.
Okay.
All of this again is written down, but we use a superior clock system, so that does everything for us, which is super nice. And then if you guys are interested in these hydroponics, the dosatron I would totally recommend. It's not a super expensive system, and it's really easy to calculate. If you want to zoom in here, you see you just set your ppm level you want, right? We have it at 200. And then that's it, and it'll do everything for you. So
okay, so it looks like it's a manual set. So you just twist the knob and change it to which setting that you want for parts per million. That is really cool, because some of these ones are automatic, and I'm assuming that that's how you save money, is because you're doing it manually.
Exactly.
Okay, so no computerization here. Just very simple. They're keeping it simple, but they're not having to buy a bunch of expensive equipment to add to it. So it looks like you have a filtration system here. About how many times does that get changed out?
We have yet to change it out yet. We're going to be checking these today, so maybe we'll today check it, but not often, to be honest with you.
Okay.
So, but if earlier you were talking about kind of the calculations we do every day, I'd like to get into that. So if you want to come over, you can follow my board. This is kind of like what I do my day to day.
Okay.
So I'll come in every day and I'll check our levels here. So we have the row 1, row 2, row 3. We check the input, output, the Licate, and then the EC and the pH. So check the input. We'll just come over here to these gallon size bottles right here, and then I'll measure the volume of this. And then once I measure that, I will measure the drip buckets. and then I'll do some mathematical equations, get the fraction, and then find out how much is leaking every day. So like right now we've been following this is pretty much kind of what it's been going consistently, about a 19% leaking on the first row, and then a 27 and a 26 on the other two.
Okay, so the Lacate is just basically a fancy way of saying how much it's losing water.
Exactly.
Okay.
Exactly. It's a fancy word of saying how much goes through the rock wool and how much actually comes out.
Okay.
And then from there, I'll take the EC of just the inputs. So basically the EC, that's checking your soluble salts, which is in the short end of the stick. Basically, you're just checking how strong your fertilizer is. So that's a really easy way to put that. And then the pH, we're just making sure it's not too high. We're looking around keep 7.5 in that area. So 7.6, 7.7 is perfect for what we're doing.
All right. That's pretty cool. So it's showing everything that you're kind of going to need to monitor in the hydroponic system to make sure that everything's regulated, that you don't have too much of something or too little of something, you know, and also they're monitoring each individual system so that they know exactly how each system is running. Maybe there's a crack in the tank and you're losing water, or maybe the drip system isn't quite working correctly.
So like right now, our first row, we've been having issues with the rock wool drying up on us, so not as much has been leaking out. So in order to fix that, we have to pump about double the input into that row instead of these two others. So just like you said, you have to check it daily in order to fix situations like that. It may not seem like a big problem at the time, but a month from now, it will be a huge issue. And then once we have our leaking buckets, I'll take those every day, and we have a dump bin, which I'll put them in, and then we pump it out into our orchard. So everything does get reused. We're not wasting any of the nutrients or the water, so everything is trying to follow that sustainable.
Awesome. So that's pretty cool. I didn't know that that was going on either. So that maybe it's not getting recirculated back to be used as nutrients in the same, like a closed loop system, but it is being used for the orchard, which is really cool because that's adding extra nutrients to those trees. So that's pretty cool. So let's go ahead and try to explain about what kind of yields you guys have been able to get from these tomatoes.
Totally. So like I said, these plants, this is the first time we've done this here at MCC, and these plants are only about 2.5, 3 months old. So we have yet to actually pick a fruit from it, but you can see on here these tomatoes, they're coming in pretty nicely. So I'm expecting in the next few weeks we'll actually start to get picking some tomatoes. But we've yet to see a ripe one yet, so just starting to get there.
Well, it is, you know, in the winter season, and you said that those plants are starting to go, but once they start to take off and put off a bunch of fruit and they can go up vertically, you're talking a lot, like pounds and pounds of tomatoes that they're going to be able to harvest.
So it's going to be a lot of, this is about let's say our greenhouse is 90 feet, so we're talking over 400 feet of tomatoes here, just rough estimate. So definitely a lot of fruit's going to be coming, so we're excited.
So let's talk about what the other students and everything do when they come in here to try to take care of the system and upkeep.
Checking the tomatoes visually every day. You want to make sure there's no viruses, checking the pest levels, checking the fruits, and then after that, we'll go in and clip up these tomatoes. That's how we're making them grow vertically. We're using these clips. There's other systems you can use. You can actually just like twirl it around the actual wire, so you don't have to buy those plastic pieces. But like I said earlier, everything was donated, so we're just using it. And then along with that, we're also looking to cut off any suckers. So I'm looking to see if I can find a sucker here. This is going to be a really tiny guy, but right here, if you can zoom in. So that guy in between that node right there, that's what a sucker is. And a sucker is basically anything that's going to produce a fruit on the plant. But in our situation, we're looking to create only one lead of the plant. So we only want to keep one top. So we want to trim all those suckers down. Different places, they'll keep 2 leads or maybe even more, but we're looking to keep just one plant for the first year.
And on tomato plants, that's a constant thing that you're going to have to do, but it's very easy. You can basically take them off with your fingers. And
you can rip them off or you can cut them. But big thing with cutting them, especially like a tomato like this, is you want to make sure you're sterilizing after every use of those scissors, because viruses can spread like wildfire in these grow situations. So that's kind of like what they'll do. And then we'll also take these J hooks to hook up the tomato flowers actually. So when they get to be bigger, like this one, it's not weighing down the branch and it doesn't break. So those are kind of the main big routines. So checking the pests, checking the plants, and then cutting all those suckers.
So what pests have you seen on the tomatoes as of yet, or have you been able to manage those pests pretty well?
Yeah, so we actually had a pretty big pest outbreak with whitefly at the beginning of building this. With all like everything going around in here, and it being not a commercial greenhouse, it being a student kind of run operation, pests are a lot more likely to happen. You know, our doors aren't always closed. There are some leaks in the greenhouse here and there. So pest populations are gonna happen. You just have to monitor them. And that's kind of the big thing. It's what your threshold is. What are you gonna allow? So like, what is that level before it gets to the point where it damages the crop or it damages your profits? So at the beginning, we did have some pretty high levels of whitefly, and I was spraying once a week with a insecticidal soap. So I basically spray it, and then when you're spraying, you really want to aim on the underside of the leaf because that's where the pests like to hang out. So I get low and just kind of spray in here, get them all covered once a week, and we want to do that for a month, especially with whitefly, because the way they reproduce, the whitefly, if you spray them every week for a month, it should kill off the entire population. So we've had those, and then we're also seeing some gnats, fungus gnats. We're seeing some fungus gnats, but the fungus gnats, they really aren't a big problem because they don't damage the plants. They're more just hanging around the leaking containers. So those two, but I'm not worried about the fungus gnats. The big deal is the whitefly so far.
Okay. And so what about diseases and stuff like that? Let's see if has there been any like major problems with diseases
so
here?
We've been seeing a few mosaic virus diseases here and there in these plants.
In your experience as a student, what would you say is some of your most valuable experiences working with hydroponic systems, and your take, because you have experience in multiple areas, like the aquaponic system versus the hydroponic system versus, you know, regular planting in the ground.
Yeah.
What do you feel about all those systems? What's your favorite? You know, all those kind of things.
It's honestly a tough question because everything, all of these systems, they have their place, right? If you do it right, they all have their time and place, which they work perfectly. But in my strict opinion, especially here in Arizona, I'm a soil grower through and through. It's just, I think our plants should be grown in the dirt. The way you gotta think about this is, take these tomatoes. When you're growing like these nice, juicy, plump tomatoes, and you go to bite into it, what do these tomatoes grow from? You know what I mean? Did they grow from nutrients in the soil that came from organic materials? Or did they grow from chemicals that were pumped into them? You know what I mean? So it's like, it's just kind of what's important to you. That's what you had to find. That's the most important verdict. In my eyes, I like to be outside. I like to have my hands in the soil. I like to grow that way. But these tomatoes, you can't grow this fast out in the soil. So it's like, it's really kind of finding that fine line. Are you looking for the best tasting produce, or are you looking for the fast growing produce? In my opinion, I like soil. I just think it's fun, but these systems are so cool. The fact that they can just grow plants out of nothing but water and a substrate like rock wool, that's amazing. But it's just what's important to you as a grower. That's kind of my
So growing organic, that's basically where we're getting at here, and I love that as well. I have taken to the soil myself, but I do like that you mentioned speed of growth. And what you're able to accomplish with certain types of plants in hydroponic systems, as well as aquaponic systems. That has its benefits as well. And closed loop systems are really cool. But
and also another benefit too is, right now with our weather, we shouldn't even be able to grow tomatoes. So we have, like I said, 400 feet of tomatoes growing right now. So that is also something amazing about it. And with our world today, the produce, how we need to have it at all times, these systems are going to be needed.
Yeah, and the fact that we live in a desert and that we have limited resources, you can conserve the water and be able to recycle it in a system is something really special and really important. So if you get your hydroponic system as a closed loop system where you can recycle those nutrients back in, then it's a really good thing. Also with starting plants, I've noticed that hydroponic systems are very good with starting, you know, seedlings.
Yeah, they are.
And because a lot of the times when you have a little plant, it needs a lot of water and those nutrients right to the roots, getting them to grow really well. That's a really huge benefit about the hydroponic system, something that I really liked. So what my plan is for the future, for my food forest and all the things that I have going on, is to do seed starters as a hydroponics system, and then take those outside and grow them in the dirt. So you get kind of the best of both worlds. And then I also put my fish water onto my plants as well, which is then encouraging more growth and nutrients as well. So it's like taking the best of everything that's out there and then
Everything
utilizing
has
it.
its place.
Yeah.
Exactly.
But I really love these tomatoes and how lush and beautiful they are, and the fact that they can grow up to the sky. Basically, we're talking probably more than probably about 8 feet or so, and that's the really cool benefit about growing vertically.
It is. And the cool thing also with hydroponics is it doesn't have to look like this. Anything in agriculture, there isn't one way to do it, no matter what people tell you. Everyone likes to say they know the best way, but you just got to figure out what works. Like a big popularity with these hydroponics is people just use the big plastic containers, the storage containers. Just cut holes into that, fill it with water, and then add some oxygen. Boom, you have a hydroponic system right there. So it's just like, there's so much you can do with these systems, and that's kind of like what we're also trying to do with just doing it here. We're trying to get them seen by the public, get it out, get the information known.
Yep, and I really like that you talked about versatility. That's what you're talking about, and that you can make these systems as simple or as complex as you want to. It could be scalable to this level where you're at a college or university, or maybe you're trying to do this as a commercial project, or it could be as small as just a little system in an apartment where you're setting up a tiny little system that you can grow actually a surprising amount of food from this, or even just microgreens. I want all of you guys to think about microgreens and the fact that hydroponics is perfect for microgreens, and you can have really high nutrient dense food to be able to eat, and you do not need a bunch of square footage to do this. There's been some systems that I've seen that it's basically just a rack that you can buy from Home Depot, and then they make it so where it's enclosed and it's inside of a one room in a one bedroom apartment, and they're able to produce a tremendous amount of microgreens, and they actually sell microgreens from that small system.
Here, speaking of microgreens, why don't you follow me? We're working on a micro. This is another experiment we're working on. We got our starts going in the rock wool like I was talking about, but instead of using those chemicals, we're going to be using strictly compost tea. So we're going to be trying to show if you can do hydroponics with all organic materials. So that's something we're working on as well. So this here, another hydroponics grow situation, but totally different. So instead of being in those rock wool containers, we're going to be growing in these big troughs here. So our plan is to do lettuce and microgreens in here, and then.
So is this going to be a float type system?
Exactly.
Raft.
That's exactly what we're going to be doing. So we have our rafts right here that we're going to be using, and then we'll plant it, and then water will be filled periodically throughout the day.
Now this is actually my preference. This is what I've been looking into as far as hydroponic systems for myself. I'm going to do a rack type system just like this, but not quite on this large of scale, obviously. And I'm going to do those microgreens and take it and then add shelves as I go. And it's just such a cool system because you can start off with one rack, and then you can build to a second rack, third rack, whatever you want to do.
Start with one rack, one grow light, and then just move from there.
Yep.
So we're really excited for this, especially with these super nice lights here.
So that's the really cool thing about this, you know, community college or any kind of college, is that there's always expansion, there's always education, there's always implementing new systems and things like that, so where you can be exposed to multiple aspects and get a full range of what the capabilities are for every system that you want to do. So this is giving you guys ideas of what you guys can do. And you know, let's just take a look a little further into these systems. So they are really heavy duty commercial rack systems we have here. Probably they are going to be some LED systems here, and it's really cool because these are all connected together.
Yeah, the technique here is called daisy chaining. That's just the technique of connecting the lights. One of our former work study students, she did that, so thank you, Megan. But yeah, so this is our hydroponic grow room.
So on these rafts, it's simply just made out of styrofoam. So you can use recycled styrofoam that comes in boxes or anything that you want to be able to float your plants on those rafts. And then they have just little cut holes through it, and then you have cups that you're able to put those plants down into, and then those go and the roots go down into the water. And I just love this because you can rotate the plants. So as they grow, you can move them down the system, and basically you never really run out of room because you're just rotating them out. So as soon as they get mature enough, then they come out of the system, you're able to harvest them, and then the younger ones are down at the end, and they can continue to keep going forward. So it's a really beautiful system to where you never stop growing.
Yep.
You just keep on moving. Sometimes with these stationary type hydroponic systems, you're kind of limited until that plant grows out.
And especially with those microgreens we're talking about, some of those plants, they have a 2-week turnaround. So, I mean, you're planting seeds and 2 weeks later, you're harvesting. So it is totally like you're saying. But earlier you were asking about our chemicals we use. So this is going to be kind of explaining it. Up here is going to be our A tank. So a bunch of fancy chemistry concoctions right there. So it's going to be the macro and micro tank. So focusing on our nitrogen, phosphorus, all of that. And then our B tank is going to be the calcium and iron. So that's going to be that red one.
Yeah. So calcium is very important, and iron, magnesium, nitrogen, those kind of things, phosphorus.
Yeah.
You know, that's the main ones that you're going to be focusing on, but there are also micronutrients that are going to go into there. So if you can see down at the bottom of this, it's NPK, and then it goes down from there: calcium, magnesium, sulfur, phosphate, and then you know, it's just pretty much the same stuff that's required in any plant growth.
Yep.
But yeah, so I'm also thinking of kind of a unique thing of kind of using recycled water from my fish, and then dumping that into a hydroponic system and be able to do it that way as well. And then maybe just adding some nutrients to that water.
Yeah, because if you're doing it that system, you're basically doing a disconnected hydroponics or aquaponics.
Aquaponics,
because you're the only thing you're not doing is you're not having the plants filter out the waste from the fish. That's it. But other than that, that's a straight aquaponic system right there. You're using plant waste or fish waste to neutralize plants. So yeah.
Yeah, and then you know, you don't have to worry about, you know, the pest situation if you needed to use some kind of thing, you wouldn't have to worry about the fish getting sick or anything like that. And then you also could add maybe stronger nutrients to the water, which would also affect the fish. So I think maybe it might be the best of both worlds.
Definitely.
We'll see how it works out, but yeah, because I always constantly drain and fill my fish system. So I'm using it on my trees and my, you know, my grass areas and all these kind of things that I have at my house. But I want to integrate it into the hydroponic system. So that will come in the future where I'll be getting those. And I really honestly want the benefit of having a ton of microgreens. I'm glad you covered that from your comments, is that you can produce so much so fast.
And they are so healthy for you.
Yeah.
So healthy. Things like wheatgrass, and they're pricey dollar too.
Yep.
So there's definitely a market out there.
So just having the right seeds, that's important. Getting them from the right source and being able to start going. So you guys get your seed in bulk, I'm assuming?
Yeah, most of the time we order from different websites. A lot of times our seed packets do just come in the regular size seeds, but things like our tomatoes like that, we will order like a 5-pound or somewhere around there.
Yeah, so if you have a large system, and also seeds are really good about storing them.
Yeah.
So even if you don't,
even
if you don't use them as fast as a commercial grower or something.
Absolutely. Keep them in your fridge. They're good for years. Like, they really are. We have some seeds that we were planting the other week from, they said we expired in 2019 and they sprouted. So it's all mumbo jumbo.
And how you take care of those seeds when they first come out, that's your success rate too. So but thank you so much for your time.
Thanks for stopping by
and doing this video with me. It was really cool to see these systems. I'm sure this is gonna just take off and expand, and it's a beautiful thing. And I'm glad that Mesa Community College has decided to run with these types of programs. And everybody, you know, just remember again that you are the change, you are sustainability. You can do anything that you want to do, and you change the world one little step at a time. So you go out there and grow, do something in your apartment, in your house, in your backyards, in whatever situation that you have been blessed with. You use it to your advantage and have nice organic food that's going to give you those beautiful nutrients that you need to thrive. No more of this bad food that has a bunch of pesticides and herbicides. You make a difference. All right? Have a good one.